I'm indeed going to pretend like there are actually people here, so you may actually get some questions from me and you, the audience. But a couple of announcements before we dive into all things JavaScript. So per the course's website, cs76.net/sections, you'll find that we've posted a Google Calendar of upcoming sections. So what exactly is a section? Well, again, it's a more intimate opportunity to get to know students in the class, to work one-on-one with one or more of the teaching fellows, and to actually explore material in more detail than we might have time for in lecture, and to also focus on the projects and also on more examples. There's going to be a few types of sections. One will be fairly traditional in a classroom, chalkboard or whiteboard or the like, and we've dubbed those the on-campus section. The first of those was to be tonight. We will proceed to film that, so if you see the video on the course's website, that is why. We'll forge ahead nonetheless. We will also have on-campus labs, which will be a section, but with everyone in the section in front of a computer, a Mac, whether we're doing the Android stuff or the iOS stuff, and you don't need to bring your own computer, but that will be at 53 Church Street on Harvard's campus, and you can click on any of these rows in this table to see where sections will be, and we'll have a few throughout the week. The idea here is that we'll try the schedule over the next week or two, and if it's not quite working for folks, we will adjust as need be. There is also, particularly for those purely distant in the course, an Illuminate-based option. Long story short, Illuminate Live is software that the course uses to enable students to collaborate with the teaching fellows online. If you click on Illuminate Live at the top left of the course's website, you will be introduced to, ultimately, a window that looks a little something like this. So Illuminate is essentially a glorified chat room whereby on the top left-hand side of the screen you will see your name and anyone else who's actually logged into the room, including the teaching fellow on duty. At the bottom of the screen you'll see a chat window where you can actually type back and forth. In theory, you can also use a microphone and even a camera to correspond with others, but generally if there's any audio or video to be had, it would be coming from the teaching fellow and not from you, so you don't need to worry about the social pressures thereof. But on the right-hand side is the most compelling part. It's on this right-hand side that the teaching fellow can present slides, can present source code, and you can actually see in real time what he or she is doing, moving the mouse, typing around, and so forth. And you can also, in theory, share your own screen if at some point during the semester you're struggling with some bug at home and you actually want to get some one-on-one assistance, but with you at home and us at home, well, we can also collaborate in that way, where you can optionally click a button. We will then see your screen. We can even then take control of your mouse with you still there watching everything we're doing, and it should enable us to be more effective teachers even if you are quite far from Cambridge. So that's Illuminate Live, and again, check out the course's website for the schedule of sections. You will also find now on the course's website a link we've entitled Meetups. So Meetups is the buzzword describing various technical gatherings of folks in various cities, generally focused on a specific topic. So we've actually been taking some input from the teaching fellows. We've been looking around in the local Boston area at least, and there's actually a good deal of geeks local to Cambridge, whereby if you're interested in getting to know fellow people about who are interested in Android, in iOS, in web apps more generally, or really just in technology and in programming, realize that this might be a fun, if slightly socially awkward way of getting to know new random people in the area. So click through on any of the links that might sound interesting, and if you yourself know of any, by all means speak up. And let me also encourage the students in the class via, say, help.cs76.net, if you yourselves would like to coordinate drinks in the square or an evening of just coding and whatnot collaboratively on your individual projects when the time comes, certainly feel free to strike up those conversations among yourselves. There's about 250 of you in the class, so surely even if a small percentage of folks is up for that trek to campus or some nearby cafe, you will have some friends and company. Any questions on logistics moving forward? Yes?
It might be too early to make corrections now, but I saw that the on-campus labs were both Monday and Wednesday.
Mm-hmm.
And if someone's taking a class, it's usually a Monday, Wednesday, or Tuesday and Thursday. Might you consider having a lab Monday, Wednesday, or a lab Tuesday and Thursday?
Good question. So in cases where people have conflicts, for those listening at home, with the current sections, so we have taken that into account, and we've also taken into account what the interest was based on that initial survey. So we're going to do our best to adjust over time. But one of those sections will be filmed every week, the idea being that you can still engage with it that way. And generally, the Monday and the Wednesday section right now, they would essentially cover the same material, so it's not meant to be cumulative as it is so much an option. And again, one of those will always be filmed. But the best I can offer, to be honest, is that ultimately it's based on supply and demand. So we'll do our best to adjust. Other questions? All right, so with regard to web apps, today we dive in specifically to JavaScript, the first of perhaps the new languages for many folks in the course. We'll move on in weeks to come to Java in the world of Android, to Objective-C in the world of iOS. But for now, we're introducing a language that has many of the same features of those languages. And even if you've never used JavaScript for all that much or at all, realize that the learning curve is actually relatively low to this particular language. Whereas years ago, it was an annoying little language used mostly to trigger pop-ups and spam and the like on the web. Nowadays, it's increasingly behind the most dynamic and the most interesting UIs that you see both in the desktop environment and also in the mobile environment. JavaScript is an object-oriented language, but it doesn't have classes like Java and C++. Rather, it has prototypes. It has objects. And we won't spend too much time on the nuances of the language. We'll do it more by example tonight and through the next and through the web-based projects. But you will find that you have many shared features with languages like C#, Java, C++, and the like. So with that said, let's start with the simple website that doesn't yet use JavaScript, but let's begin to add to it and then discuss what you can do with JavaScript, why you should care perhaps about JavaScript, and let's increasingly get, by the end of today, to some particularly compelling web applications. Small web applications, but at least so that we have some fundamentals with which you yourselves can tackle your first assigned project in the course. So here is, I argue, a mobile website, right? I'm not very good at making mobile websites yet. I've only attended one lecture of a class like this, and yet I know HTML. I know the H1 tag for making a big, bold heading. I know the UL and the LI tags for making an unordered list. And I argue, because I can view this web page on my phone, it is a mobile website. Maybe not mobile application, since you can't really do much with it, but it is at least mobile. But this is not surely what the world has come to expect, even over the past couple of years when it comes to mobile experiences. For one, we humans have pretty fat fingers, and touching a blue underlined link is not so easy as it is, say, with a mouse and an arrow that would very specifically point to it. Two, there's really no impressive aesthetics here going on. I mean, this is sort of HTML 1.0 stylization of the page, and surely we can do better, not just aesthetically, but also functionally. So it's a lot easier, it's a lot more obvious what I can touch and where I will be led when I do touch things on the screen. But as you've seen with Dan last week and just a moment ago with some of the tags he's had in his examples, it's not as simple as just taking a snippet of HTML and pulling it up in a mobile phone. Well, let's take a look, for instance, at this very simple implementation of this page. Okay, so let's start with the simplest of source code for a mobile website, and we'll make all of the source code available on the course's website, so you don't have to scratch everything down now. But I argue that this is, in fact, HTML5. We're using the very simple HTML5 doc type. If you look up higher in the file, it just says doc type HTML. We have some useful tags that are not necessarily required, but it's not a bad habit to get into including the lang attribute on the HTML element to specify, particularly for search engines benefits or for crawlers benefits, that this page is in fact in English. Now this can most likely be inferred, but again, in the interest of good semantics, it's a good habit to specify this is not only English, but US-based English. The character set, UTF-8, this too is something that can generally be inferred. This refers to the types of encoding that's being used for characters in the page, whether it's for sort of simple ASCII characters versus Asian languages with much more interesting character sets. This helps provide the tool with a hint as to what to expect and how to read it. But for the most part, all of the rest of this should be familiar. Anyone coming with even a modest background in HTML should see some familiar tags here. In fact, there's really no magic. We have the title element in the head. We have the body with an H1 tag, as I alluded to earlier. We have the UL and the LIs there. And that's about it. But if you pull up this page in a mobile phone, and for clarity, I'm just going to use the simulator instead of actually using my actual phone here. If I pull up this page in the iOS simulator, what we will see is that this is actually a really crappy mobile website. I mean, just look how small it actually is. But if you consider, proportionally, that's kind of what it looks like in my browser. If I go back to my browser window and realize that because we're using this projector in this room, my browser is actually not all that wide. It's 1024 pixels across. And sure enough, this is taking only up a very little portion of the screen. Well, we saw this with Dan's examples last week, that unless you actually specify or provide a hint to the browser as to what resolution or width you're expecting, well, it's going to assume essentially that you expect a really big screen there. So this is already a bad starting point. So let's fix this. So this was home1.html. What I'm going to go ahead and do, though, in home2.html is just make one change. And again, we've seen this before, but this one line here, the so-called meta tag that certain browsers, WebKit in particular, tend to rely on for additional features. This, as we saw earlier, specifies that the content of this page does indeed have a width that's dynamically defined. I'm not even hard coding it to be like 960 pixels for the iPhone. I'm saying it's device-width. And this is sort of a special symbol that denotes the actual device, whether it's an iPhone, an Android, a BlackBerry, its actual width. And so what happens then, if I actually pull up this version of my home page for the course, Home 2, now it's much more compelling and it's scaled appropriately. But we're really not there yet, right? We're still using blue links. Being able to touch that with a fat finger is not the easiest thing in the world. Can we begin to do better? Well, let's go ahead and take a look at how we might begin to modify this. So I'm going to go ahead and in home3.html, I'm going to add one line of code here, link tag to ios.css. And I'm just going to slowly try to build up some interesting CSS with which to stylize this page so that it does feel a little more familiar, a little more Android-like, a little more iOS-like. And to do this, I'm going to go ahead and create iOS. Let me just move this one aside for a moment. I'm going to create ios.css. I'm going to make the permissions appropriate, but these are details we don't need to worry about in some environments. And now I've got a blank slate. Now, what tags do I have to care about? Well, a moment ago in my home page, there's not all that much. There's an HTML tag. There's a head tag. There's a body, H1, UL, LIA. I mean, it kind of is the basics here. So let's start perhaps with something as specific as possible. Let's stylize the anchors, because I'm clearly picking on the simple blue underlines. So let's specify that an anchor tag that's inside of a list item, so recall from CSS, or if unfamiliar, know in CSS there's this notion of hierarchy. So if you don't want to specify all anchor tags, but just those anchor tags inside of li tags, you say li space a. And I'm going to specify that I don't want these things to be inline elements anymore. I want them to be a block element. And for our purposes, inline means it's like a bold tag, an italics tag. Anytime you have a piece of text generally that's inside of some other piece of text or imagery, such that you don't want it to take up the whole width of the screen, you want it to stay where it is, that's an inline element. And that's how links generally are rendered. In general, on a web page, CNN.com, a link is embedded in a huge paragraph. It doesn't take up the full width of the screen. But on an iPhone or an Android device, I generally want, or at least we're used to these days in UIs, having the links take up the whole width of the screen. So by specifying display block, this thing's actually going to take up the whole actual width. Well, let's go ahead to the simulator and see what the effect of this simple change alone is. In Home 3, let me go ahead and open up Home 3 here. And now I have, not all that much of a change. Well, this is not to be unexpected because there's no actual text to the left or right, so we can't actually see this yet. So let's see if we can't make it a little more obvious what's going on here. Well, instead of that, let's go ahead and do this. I'm going to go ahead and flesh out some additional features, and I'm going to add to my li anchor tag a few other aesthetics. So I'm going to give everything a border bottom, because in Android and iOS, anytime you have these lists of menu options, you generally do see a line separating them. So border bottom 1 pixel and a gray solid line. I'm going to make the text be just black. 000 is black. I'm going to display block, but that's where I started. Font weight bold to make things really stand out. Padding is just an aesthetic to give it some white space around it, and I want to get rid of those blue links. So text decoration, none. Well, let's jump ahead and see what else I can do. I also thought the bullets were pretty stupid, right? They're pretty inconsistent with a mobile UI. Well, if unfamiliar in CSS, if you want to get rid of the bullets in an unordered list, you specify that the list style should be none, as opposed to actually rendering something like bullets. And let's see what more we can actually do. There's one detail that you really figure out by trial and error, but notice on the body element, I've also specified a margin of 0. This is a headache even in the desktop browser world, whereby you very often get a white border or white edge around most any browser window. Specifying margin 0 gets rid of that. Font family Helvetica or sans serif at least ensures I'm not going to have a Times New Roman kind of mobile website. And then the interesting stuff is really for the header. And there is, as Dan said, some WebKit specific features that I'm happy leveraging because it will work on many devices, Android as well as iOS phones. And I'm going to specify that the header, which is currently CSCI E76, instead of just being big and bold and boring, I'm going to instead specify that it's going to have a background color. And that's a hexadecimal code that essentially represents a blue shade. Background image, it's not actually going to be a file, and we won't dwell on the specifics of this because they're a little detailed and a distraction today, but dash WebKit dash, again, denotes here comes the WebKit prefix, so this is WebKit specific, WebKit being on many of the major mobile phones right now. And long story short, this creates a sexy gradient that you might be familiar with if you do, in fact, play with an iPhone or an iPod Touch. The text is going to be white. The font size will be 18 pixels, no margin, a little bit of padding, align it in the center. Well, what's the end result? I take the exact same HTML that I began the class with saying this is a mobile website, even though it was quite poor at that. And now I take that same HTML, apply this style sheet, which is only a couple, maybe 20 lines of CSS, and now we have something that's immediately more reminiscent of an iPhone interface. And in fact, if I now click on syllabus, because this is an actual link, this is, as we would expect, does not render in a huge form because this is an actual PDF of the syllabus. But now we have arguably a much more compelling mobile website. But what about lectures? Well, what did lectures link to? Well, let's take a look. In my home page's HTML, notice that lectures is a link to lectures.html. So we can implement this notion of hierarchy that you see in the Android world and the iOS world. So let's click lectures and notice that we then end up here. Well, that's no good. We seem to have a little mistake with lectures.html. So what tag am I missing that's causing this to render in such useless form? So not the H1 tag. It's actually there. If I zoom in, you can kind of see lectures there. And it's just not quite scaled right. How did we blow everything up to be sort of more mobile specific? What was that tag? I can steal it from my own homepage because it did used to work. It's what Dan showed. It's this meta tag that says to the browser, hey, assume a much smaller screen than you might otherwise. So let me go ahead and plug this in here. Meta name viewport width equals device width. Save that and reload the lectures page, and hopefully, voila, we're back to a comfortable mobile space. And what have I done here? So this is lectures.html. I won't bother showing the source because it's pretty much copy and paste from what we just saw. It just has one menu item because we've only had one lecture prior to tonight. And my goal now is to enable users to click on lecture 0 and access the resources that we had last week. Well, again, I have this stylization bug, so let's fix that. This is lecture0.html. I'm going to go ahead and plug this in. And now we're back to a good place. And just to summarize where we came from, here's our course's mobile website that we're making on the fly. I click lectures and I end up here. I click lecture 0 and I end up here. And now I can go ahead and click on, a little copy paste overzealousness there. This next one was meant to say syllabus. Now I actually have a rendering of several different things here. And in fact, if I go and click on syllabus, I'll see the PDF. If I go ahead and click on video, it will actually play the video from last week, though we don't need to revisit that week. And we have indeed a mobile website. Now this seems a little iPhone biased. Doesn't help that I'm actually using an iOS simulator. But if we ignore the metal surrounding here, let's see if we can at least do justice to another platform. Let's go to home4.html, and this, for those of you with Android phones, might find a little more familiar. Whoops. OK, I cheated. I linked to the wrong one. But at least on this menu here, you see the more familiar black and slight grays. And we can add the orange or green that's very common in the Android world. It's just CSS. There's really nothing all that interesting there. But what is missing is, frankly, the sexiness of these devices, right? We can click and drag and things bounce around. In fact, when you generally click on menu options on either platform, things don't just change to the next page like in the desktop world. They glide. They slide from left to right. So how can we actually get to that point with our code? Well, let's go ahead and introduce the first of these libraries or APIs that we mentioned last week. So let me skip this here. So jQuery Mobile. So this is a library, freely available. It's still in sort of pre-release phase, an alpha phase, which means it's not quite fully robust, as it hopefully will be in a few weeks or a few months. But it's pretty darn good already, and it's already pretty feature-rich. For those unfamiliar, jQuery is a very popular JavaScript library that we'll look at very briefly today, and perhaps in sections this week, that just make a lot of tedium in JavaScript go away, and things just a lot more readable and a lot more pleasurable to type. But this mobile-specific library allows us to do this. I'm going to go ahead and open jqmobile.html, whose source code I'll put on the course's website after tonight. And notice a few details this time. In the head of this page, I'm including some CSS, but I didn't write all of the CSS myself this time. Notice that the URL is a bit long, but it's pointing to jQuery.com/mobile/something. jQuery mobile minimized.css. So this is just someone else's style sheet that comes from this library. How did I know what to type? Well, I just read the manual and I copied and pasted what they told me. But I also need to include some JavaScript. So we saw a bit of JavaScript with Dan. We'll see a bit more in just a moment. But I'm specifying that I, one, want the jQuery library itself. So this jQuery mobile library assumes that you're using jQuery. And then I also need the jQuery mobile library, which is, again, a copy-paste from the manual telling me what exactly to include to make this work. And then I've got my title, my close head, my open body. So let's actually see now, how can I implement the same course's website using this library without kind of having to implement home3.html, lectures.html, lecture0.html, because if I'd actually pulled up the code, as I said verbally, it's a lot of copy-paste. It's the same damn thing again and again and again. And you saw even my own error, and I overzealously copied some of the CSS lines. So it turns out with jQuery Mobile, you can do things like this. This is an aspect of HTML5 that's nice. You can have an attribute, almost any element, that it starts with the word data and hyphen, and then you can have any suffix there. And the upside of that is that without breaking the validity of the page, you can essentially define your own attributes that you can then use in JavaScript particularly to morph these elements into other elements altogether, to add effects, to add stylization. It allows you to tag, essentially, or add semantic data to your tags so that you can manipulate them in actual code, which we'll begin to do tonight. So notice that at the top, I have a div data-role equals quote-unquote page. So by reading the manual, I realized that the jQuery mobile library has decided that you will model with HTML markup your pages by calling them quote-unquote pages. Their role is that of a page. If you want to be able to uniquely identify them, you give it an ID, like you might be familiar with in HTML. So I do ID equals quote-unquote menu. But then there's subcomponents of a page. Again, the manual held my hand through this, and I found that, OK, there's another role inside of a page called header, and that's where I'm going to put my H1 stuff, the title of the page and the blue bar or whatnot. There's going to be a content area, which is the guts or the body of this mobile page. And then there's an optional footer, which I didn't even bother doing because I was mimicking my original UI. And notice what I've done, though, inside the content. I'm using an ordered list, but the role that this unordered list plays is that of quote-unquote list view, which is something specific to this library that understands now this attribute. Data-theme equals quote-unquote C. At the moment, the library ships with 7 or so themes, colorizations, and whatnot, and C is the one that looked the prettiest to me, so I chose that for the moment. Well, now the rest is pretty familiar. I've got a list item and a list item for both lectures and syllabus. I have an anchor tag inside, but notice one change. Whereas my PDF for the syllabus is still just a long URL as before, what's curious about the anchor tag above it for lecture, for the lectures? It's no longer a link to lecture0.html. What is it apparently a link to? Yes, and back. OK, so sharp lectures, yeah, so it's this fragment ID, right? And in the world of desktop browsers, recall that these fragment IDs generally whisk you away, up or down on the page to a certain demarcation of the page. Well, here it's being used to refer to an ID that's elsewhere in the page. So in fact, scroll down just a little bit. That was my first page, but I'm inside the same HTML file. Notice what I'm about to see here is kind of curious. Now I have another div whose data role is page, but whose ID is lecture. lectures. Notice the coincidence. I had sharp sign lectures a moment ago. Here is the ID lectures. It too has a header as a data role up there. It too has content, and it too has an unordered list whose role is list view, and a list item in A. And what is its anchor tag pointing to? Lecture 0. So if you make the mental leap now as to where we're going with this, now I'm implementing the whole user interface for the course's mobile website inside of one HTML file. And I'm using separate divs to represent each of the views of this application. The first big div, whose role is page, represents the main menu. The next div, whose role is also page but has a unique identifier of lectures, represents the next level of the menu if you kind of dive in. And then from there we get to lecture 0, and from there we get to the video and so forth. So what's nice now is that I can embed my whole application inside of one HTML page. I therefore don't have to incur multiple round trip times for HTTP requests to get more data and the latency that's involved in that. I can embed essentially my application using markup here, but what seems to be absent is any coding now. How am I going to click lectures and have the screen whisk away like it does in a native app and then reveal lecture 0 without actually writing code? Well, thanks to these attributes that are predefined by this particular library, the data role and the data theme and so forth, the library that I included with the script tag and the link tag up top is going to do all of that magic for us. And so the end result is this. This is just one file called jqmobile. And this is jqmobile.html. I hit enter. The UI looks familiar. In fact, your UI is kind of better than mine. Notice the arrows that I kind of cut corners on and didn't even try implementing before, but I could have using a background image that's aligned on the right-hand side, sort of old CSS tricks. Let's click lectures. Now notice, that's kind of sexy, right? This time it slid over, no latency, no progress bar, anything like that. Notice there's a back button that I didn't even get around to implementing myself from scratch. So I can click lectures, lecture 0, and voila, there's all of my same content. I can go ahead and click on the slides, and sure enough, here are the slides from last week's lecture. And so here is one approach. It's using JavaScript, but thus far all of the details have been hidden for me. So let's now start to dive in as to how this library and others can actually do that, and how you can begin to manipulate the so-called DOM, or document object model, to actually make more compelling user interfaces. So here we go. Here is a very simple snippet of HTML code. We've got the doc type up top. We've got a HTML element with a head and a body. Inside of the head is just the title. I wanted to keep it super simple. Inside of the body is just a link for quote-unquote my link, and then an h1 tag, because I wanted something other than an anchor. So very simple HTML. And notice, as is most people's habit, the indentation. There's this hierarchy, both conceptually and often aesthetically, to HTML with the indentation. That's just a sort of tree structure, a family tree of sorts, where there's one root element, the HTML element, beneath which everything descends, or to the right of which everything kind of grows laterally. So we can depict this HTML using what folks generally call a DOM, the document object model. And this is the fancy way of describing really a tree structure. If you think back to any data structures class, we need a special node that's generally called the document node, because it turns out even though the HTML tag is the root element in a web page, well, there can be some stuff above it. The doc type tag, there's things called processing instructions, there's comments, and a whole bunch of other things that can be even higher. So there's this special node, and we'll see this same name, document, in the world of JavaScript. Beneath the document, though, hangs the root HTML element, which is right here. That HTML element has two children, so to speak, head and body. The head tag, in turn, has a title element, but it doesn't quite stop there. Even though you don't see any more tags inside of the title, the text in between the open title and closed title tag is itself another node, so to speak, another box in this picture. And so it's what's generally called a text node, but it's part of this tree, part of the DOM, and we'll see in JavaScript, part of the data structure we can manipulate programmatically. Body elements is the same deal. We have an anchor tag and an h1 tag that are children. The h1 tag has some text beneath it. The anchor tag has some text beneath it. But the anchor tag also has an attribute, in this case an href. It wouldn't be correct to show the href attribute as a child below the node, because attributes are not children, if only because they themselves can't have children, if you just think about the HTML. And so this is just one, this is an artist's artist's rendition of how you might depict an attribute while still making clear it's not a child. But this is really just a pictorial representation. It's the idea that's important. Elements or tags can have children in the picture and descendants. Attributes cannot. They're terminal pieces of data. So kind of keep this picture in mind, because almost anything we do with HTML henceforth, whether it's in the context of web apps specifically or even embedded web views in Android or iOS apps, will assume that you both understand and know how to navigate and edit and add to and subtract from this tree data structure in memory. So let's take a pass at this. So JavaScript is actually pretty familiar if you've used, again, most any of these higher level popular languages today, C, C++, Java, Python, Ruby, whatever. All of them share a fairly basic core. But how do you actually use JavaScript? Well, we've actually seen by example already, both in Dan's stuff and my snippets of jQuery Mobile, you can use the script tag. At the very top of your file, inside of the head, you can just start writing JavaScript code. Now, there's some nuances that are worth keeping in mind, both in the desktop and mobile world. If you ever want to do mathematics inside of your code, which isn't unreasonable, presumably you've at least once in your life when writing code said, is x less than y? Something like that. But what's worrisome is the less than. That angled bracket actually has special meaning, obviously, in the world of HTML. And so the reason that most folks are in the habit of encapsulating any of their inline code with the so-called C data tag preceded by comments is just to make sure that the browser doesn't choke on otherwise benign syntax, like a less than symbol or even an ampersand, which can also cause worries because of its conflation with entities. So where the ... is where I could start writing JavaScript code. But what we've seen thus far, at least in jQuery Mobile's API, is that we actually embedded a JS file that it's self-contained code. And so you can embed code by specifying OpenTag script source equals, quote unquote, the path to the file that actually contains it, the type of it, the MIME type here. And it's a little stupid, but you should also close the tag here and put nothing inside the open and the close tag, for compatibility purposes. What can you expect syntactically? Well, if you've ever seen a break statement, continue, do while, for, return, switch, most of those are pretty common to many procedural languages. Then there's try catch, which is common in any language that supports exception handling, which JavaScript does. There's the keyword function, which is interesting. In JavaScript, it's actually really easy to create dynamically, that is, while your program is running, brand new functions. They're so-called anonymous functions or lambda functions, and they're wonderfully useful and present throughout JavaScript, especially in the context of APIs, because it allows you to define what are generally called event handlers. Well, what's an event? The web's whole implementation or browser implementation really is event driven. You click on something, that's a click event. You drag something, that's a drag event. You touch something, that's a touch event. And the idea behind functions more generally in this context, or function handlers, is that you can register in the world of JavaScript a function who's supposed to get called anytime a certain event gets triggered. When the human's finger touches the screen, the touch event gets fired, so to speak. A function that you've registered as the event handler, therefore, should get called, and your function can then do something with the XY coordinates of that touch, or whatever element's actually being touched. So this will be a powerful feature indeed, but syntactically, there's not all that much scary new syntax to actually pick up. In fact, some of the most useful syntax is useful because it's so darn succinct. In JavaScript, if you want to have a numerically indexed array and you want to create this array, you actually don't have to know in advance how big it is. So it's really more of a vector, if familiar, than it is an actual array. And if you want an empty array, you can simply say open bracket, close bracket. And that will give you an array in memory. Or more specifically, to put this in context, let me go ahead and pull up a little toy application. If I want to specify a variable called my let's say grades, if I want to store all of my numeric grades for the term, I say var in JavaScript to define a variable. I say a keyword like grades equals open bracket, close bracket, semicolon. Bam! I now have in memory an array of size 0 that I can begin adding things to using familiar square bracket notation. But also in JavaScript, there are objects. It's indeed an object-oriented language, but it's so easy to create objects, even more easier than in a lot of server-side languages, because the syntax is as simple as 2 curly braces. If you want to create an object, creating an object is as simple as it was to create an array. And we'll see what the difference really is here. If I want to create an array that represents a student, or rather create an object that represents a student, I can do something like this, but unfortunately this student is literally empty. There's nothing to this particular student. So what is an object? Well, an object is just a data structure that contains key value pairs. A key might be ID, and the value of that ID might be 1, 2, 3, 4, 5. If some student's ID number is 1, 2, 3, 4, 5. But a student might have other keys associated with him or her. A name, a dormitory, a hometown, and any sort of pieces of data that you might want to associate with the student can be thought of as keys inside of an object. But much like other languages that you might be coming to the course with experience in, objects can also have methods or functions essentially inside of them affiliated with that object so that you can actually call a function to extract some piece of information out of an object whose answer might change over time. Objects don't have to contain static information. They can contain essentially pointers or references to functions that can return dynamic data. And in terms of syntax, if I want to define a student object that's actually more interesting than this empty student, I might say ID colon 1, 2, 3, 4, 5, comma, and then name might be quote unquote David Malin, and then I might say dormitory equals, let's say, Mather, and then I'm close the curly braces, semicolon. Now this is a stylistic decision, the fact that I've hit a space bar before ID and name and dormitory, the fact that I've hit the carriage return after the open curly brace, but this is very often the approach people take stylistically in JavaScript to define objects. It's actually very easy to define key value pairs, and in fact what the syntax you're seeing here hints at a technique, or rather an encoding mechanism called JSON. If you've ever heard of JSON, which is very much the rage with the world of Ajax, which we'll look briefly at tonight, realize that this is essentially the encoding scheme, the textual representation of objects that's transmitted back and forth across the wire to represent interesting data structures. Similarly, are arrays represented with square bracket notation. Any questions on objects or arrays in JavaScript? All right, let's go ahead and take a 1-minute break, swap tapes, and we'll forge ahead. All right, so let's do something somewhat simple with JavaScript, but then very quickly move on to more interesting dynamic things using this technique called Ajax. A teaser here is that Ajax essentially once upon a time stood for asynchronous JavaScript and XML, but really this is just a fancy way of saying it's a technique in browsers whereby using JavaScript you can request more information, more images, more data, more anything from a server after the original web page has loaded. And this is in contrast with just a few years ago when the only way to change what the user was seeing in the web page really was to have him or her click a link or respond to some event and the whole page would refresh. And you'd see a little spinning icon. You would see the screen go quickly white before actual new content came in. And this certainly was to the detriment of a more fluid user experience. So Ajax is a technique that uses JavaScript to make these UIs much more dynamic and much more native-like, so to speak. So let's take a look at this. So this is a web page here, but I'll open it up in a phone in just a moment. This is just a very simple form mechanism. You can imagine a user visiting a website and being asked for their username, their email address, their password again, and then maybe have to click some annoying box to agree to some terms and conditions. So what this form does isn't so interesting tonight, but how we navigate and manipulate this form will be of preliminary interest here. Because in fact, this is driven by HTML. That HTML, if it's nicely well formatted and valid, can be represented as a tree in memory, that so-called DOM. It's the browser whose purpose in life is to read HTML, top to bottom, left to right, and create in RAM a data structure, a tree that represents that code. And now it's up to us, the developer, to actually traverse that tree from the root on down and update or access the DOM as we see fit. So I'm going to go ahead and open the source code for this. This will also be available online. This is form1.html. And notice there's some mostly familiar code here, if you know HTML quite well already. My HTML tag, head tag, body tag, form tag. We didn't see that before. But again, even though you might not have ever made a mobile website, really at the end of the day, it's just going to be HTML, CSS, possibly JavaScript, and so you can use these familiar constructs. So I've got a form whose action happens to be dump.php, which is just a stupid little script on the server that just shows me what the user submitted, just so I could do a sanity check, but that will be not too interesting right now. Method equals get, so that everything goes in the URL, but it could be post, and there's a field for email with an input tag, password, input tag, and then a checkbox here. So hopefully some familiar HTML. But again, keep in mind, this HTML is going to be loaded into a tree-like structure, and each of those so-called nodes is in effect going to be presented to you, the developer, as an object. And an object can have properties like, is this input element checked or not checked? Is this input element disabled or not? What is the value that the user typed into this input field? So now, even though you're looking at HTML, realize that the real magic derives from this thing being a tree structure in memory, each of whose nodes we can now access as though they were native JavaScript objects. So let's see what this does when I fill it out here. I type some stuff, password again, check the box, and I can submit. But if I submit, everything goes through. What you're seeing here is just that result of dump.php, which just shows you what the user actually typed in. But if I look at version 2 of this thing, form2.html, now let me transition to the simulator so that it actually feels a little more mobile in nature, even though the fundamentals, at least for today, are going to be the same as those you're already familiar with, perhaps. This is forms. Here's that same form, but now there's a second version that's actually going to do some sanity checks for me. So in this version here, I have a field for email, password, but you know, I'm a little anxious. I don't want to give this website all this information, so I click submit. But immediately now I get this alert from the server, which happens to be called cloud.cs50.net, one of our course servers. But the error message is you must provide an email address. All right, well, let's go ahead and do this. I'm going to go ahead and type dmailin@harvard.edu. Whoops, wrong interface. dmailin@harvard.edu. Click submit because I don't want to choose a password. You must provide a password. So clearly there's some error checking going on here. Maybe an if and an else if and that kind of stuff. So let's actually look briefly underneath the hood as to how this is actually working. Well, it turns out that little error message we're seeing is just the result of the alert function, which frankly in the desktop world is pretty darn annoying and pretty darn inconsistent. It appears in all different places inside of a browser, but we're using it as a simple feedback mechanism. We could do something fancier, and we will before long, but for now, let's just keep it simple. So what's going on inside this file? Notice that I have a script tag with some inline JavaScript, so I just decided that I don't want to put this into a separate file. I'd rather put it in the file itself. So let's look briefly at the form. Take my word for the fact that all of the HTML is the same, except for this thing here. Unfortunately, it's wrapping onto 2 lines, but notice that the form tag in this version of my code, form2.html, actually has what we'll call an event handler, that same word I used before. OnSubmit is an HTML event handler that takes as its value a quoted string of potentially JavaScript code. The JavaScript code I've put there is just return, validate, open paren, close paren, semicolon. So this is hopefully a familiar procedural call where I'm calling a function that apparently is called validate, and I'm returning its return value. What does that mean? Well, it turns out that in this context of the onSubmit handler, if you return false, the form will not get submitted, even if the user hits submit. If you return true, the form submission will proceed as though nothing were anomalous. So my goal in life now is to implement the validate function in such a way that it returns false and maybe even yells at the user if he or she does not cooperate with my instructions. So here's the validate function, and again, it's in the script tag up top here. If document.forms.registration.email.value. So this is unfortunately verbose, and there are more succinct ways of stating this, both in JavaScript itself and also with the help of libraries like jQuery. But for now, we're going to use some very sort of low-level basics. Document is that special root node that stands on top of the whole tree. .forms is a special object that's actually a property of document. So inside of that document object is another object called forms, and inside of that forms object are all of the forms in your current web page. In this case, there's just one, and I did give it a name. Forms.registration specifies, give me specifically the form that whose name is quote unquote registration. So I had the foresight here to not only define a form, but also give it a name so that I could reference it symbolically in my code up top. So now if I go back to this code here, notice what I can now express. Document.forms.registration. It's verbose, but it kind of illustrates that we're starting at the root, taking a step into forms, taking a step into the registration form, and now taking a step into the email input field, which itself is a node in the tree. And that node, because it's an input element, has potentially a value, whatever the user typed in. So I'm really just asking the question, is what the value of the email field that's in the registration form, which is itself in the document, the whole web page, is it equal to quote unquote? In other words, did the user type nothing? And if so, what am I apparently doing? If the user typed nothing, what code gets executed? Sorry? So the warning, I call the built-in alert function, sort of poor man's tool to error response mechanisms, but it gets the job done, and it gets it done pretty effectively, frankly, in a mobile environment where it takes up the screen anyway. But then, even more importantly, I return false in order to make sure to terminate the form submission so that the user actually cooperates here. Now, as an aside, doing these client-side JavaScript-based error checks is not sufficient for security purposes. This is not so much a server-side course as it will be a client-side application development focused course, but realize that if you just trusted that anytime a form did get submitted, that a username would be there, or an email address, and a password, and another password, and the checkbox checked, that's not a good assumption to make, because any adversary or anyone with JavaScript disabled, frankly, in their browser could submit unintentionally or intentionally bogus data to your database, which might screw up your database tables and just generally provide you with data you don't expect. As for other features here, I'll wave my hands at some of it because a lot of it is redundant even though it's expressing slightly different sentiments. But notice this, you can kind of infer from the words what's going on. Is the password1 field's value not equal to the password2 field's value? Well, what is password1? What is password2? Well, it's just the names I gave to those other two inputs, both of which were of type password. So if the passwords are not the same, I yell at the user here, you must provide the same password twice, and I return false. And you can come up with any number of other error checks, but for now, the takeaway should be, here is how we access that document object and properties thereof, keys inside of that object, and we can start to navigate from top on down the so-called DOM of a web page. All right, so any questions on form manipulation? No? All right, so let's now introduce a fancier feature. It's moving quickly, but a lot of this starts to feel natural pretty quickly, especially if you've been doing web development even in a desktop world. So here's a scary looking picture that essentially defines this notion of AJAX. So AJAX is, again, a technique. It's sort of a combination of existing technologies that now have a new label when you use them all together that allows a browser to make additional HTTP requests from browser to server, get back the data, and embed that data really smoothly or fluidly without the user seeing a whole huge page refresh, without them necessarily seeing a spinning icon. The interface for the user can be much more dynamic. How does this typically work? Well, in this picture here, this is the browser, the user interface. A JavaScript function gets called. How? Maybe the user clicks something. Maybe a timer went off. It's time to get more data. Something triggered a JavaScript function to get called. That function instantiated, in object-oriented terms, what's called in JavaScript an XML HTTP request object, which is just a special object that comes with modern browsers that has the ability to send GET or POST requests to a server and get back more data. So it creates that object. The JavaScript function configures it with the URL that it wants to fetch data from. The HTTP request goes to the web server. The web server does its thing, responds here with, back in the day at least, XML data, which is like HTML, but you get to invent your own tags and attributes. It then goes back to what's called a callback function. So here too, JavaScript is all about, in this context, the invocation of functions, sometimes asynchronously, whereby this is a different function than the one that triggered this HTTP request. But I probably wrote this function too. Inside of this XML response, might be HTML, might be some text, might just be some interesting data. It's then up to this function to manipulate that data and then insert it into the user interface. So let's actually see this, because that's kind of a mouthful, but really at the end of the day, it's a fairly simple idea by way of example. So this time I'm going to go into, again, the simulator for just a phone here, and I'm going to go into my Ajax directory. This code too will be available online. And I'm going to do something pretty boring at first, but just to illustrate what's possible. So here's an HTML form. I've specified the meta tag so that the device width isn't crazy wide, and so it actually is somewhat navigable here. Still feels a little small for a finger, but we can worry about the CSS when we actually try to commercialize something like this. But for now, we just have an input field that's text and a submit button. But what's going to happen here is this form isn't going to get submitted to the server. Rather, I'm going to have some JavaScript code that's listening, so to speak, for the user's touch of the button. And rather than submit the form in sort of the old school HTML way with a post or a get, it's instead going to call a JavaScript function, which is going to create one of those XML HTTP request objects, which itself is going to talk to my server, where I have a little script I wrote that talks to Yahoo Finance. We're going to ask Yahoo Finance, what is the current price of whatever the user just typed in? Yahoo will hopefully reply to the server. My server will hopefully reply to me, the browser. And at that point, the so-called callback function will get executed. The second of two JavaScript functions involved in this whole story. And that function, the callback function, is hopefully just going to trigger an alert onto the screen to tell me what the current price of, say, Yahoo is. So let's try this. I'm going to go into the text field here, and I'm going to type YHOO for Yahoo's stock price. I don't want to let autocorrect kick in there, but we could disable that with the tag or with an attribute. I'm going to click Get Quote. A little bit of spinning, and now the server, again called cloud.cs50.net in this case, returns 16.38. Which means as of 4:30 or so p.m. Eastern Time today, that was the current stock price of Yahoo. Now, this is kind of a bad website, right? I don't want to have to like click OK and close an alert window every time I interface with this website. So can we do a bit better? Well, in version 2 of this, it turns out you can not just alert the user, literally by calling alert, you can instead insert that price into the DOM. So I'm going to again type Yahoo's stock symbol, YHOO, and I'm going to then click on Get Quote. And notice what happens to the bold-faced to be determined. This time, it subsequently changed. And if you were watching closely, you would have seen in the progress bar of the simulator that there was actually some spinning. The server got contacted, but the whole page didn't refresh. Rather, I simply updated the so-called DOM. So how did I do this in each of these cases? Well, in Ajax 1, we had this code. Here's the form at the bottom, and the form is very simple. Form, but on submit equals quote unquote, quote, sorry for the confusion, but the function is called quote. And notice this time just another technique. I don't have to have the function return the return value I want to return. I can instead just say semicolon and then another JavaScript statement, return false. So realize this is quoted code that you can embed here in the attribute of this onSubmit handler. So what is the quote function? Well, it essentially operates in two parts. Notice at the very top of my script tag, I first defined for my purposes a global variable called XHR, XML HTTP request. I then have my quote function, and now I frankly have to jump through some hoops to tolerate both Mozilla-based and WebKit-based and Internet Explorer-based browsers. This is less necessary in the mobile world these days, but if I want this code to be pretty portable, I went ahead and jumped through these hoops that generally a library like jQuery would do for you. So I create an XML HTTP request object. I assume that it works if I get past this point. I'm just checking for null in case this is like Netscape 1.0 or something silly like that. But at this point in the story, I get to now do something with the user's input into this form. I construct a variable, var URL equals quote unquote something, quote1.php, which for our purposes, consider it to be a black box. It's a script that I wrote on the server that's designed to talk to Yahoo Finance and then send the response back to me. But it's a GET request, so I can say quote 1.php question mark, symbol equals something. So what does it equal? Well, I use document, and rather now jump through some hoops like last time, document.forms.registration, I can now actually get the element in the DOM that I want, because this time I had the foresight to give the thing I care about an ID. So I say document.getElement by ID. Notice the capitalization. It's actually quite important, and things will break if you are not mindful of the appropriate camel casing here. Document.getElement by ID, quote unquote, symbol. What is that? Well, for now, assume that that's the text field that I created in HTML, .value. That's going to give me whatever the user typed into that box. And why? Why does that ID work? Well, if we scroll down, notice in my HTML form, I did indeed give this input field an ID of quote unquote symbol. So now, thankfully, because of the document.getElement by ID function, JavaScript has the ability not just to traverse the DOM looking for things, but it can jump right to specific elements thanks to my more efficiently having decided to give it a unique identifier. Now I get to send the so-called AJAX request. I first say this: my XHR object, which is that global variable, has an onReady state change handler, which for no good reason is all lowercase this time, but this is a property, equals handler. So notice this curiosity in JavaScript. Much like in C and C++, you can pass functions by their name, essentially by reference or by pointer. And so in this case, I'm not saying make a copy of the function. Rather, I'm essentially saying call this function when the state of this AJAX thing changes. Why might it change? I get a response from the server. Then I call open. I'm using the get mechanism, and then I'm specifying the URL that I constructed as part of this variable here. True means make this asynchronous, which is the A in AJAX, which means don't pause the whole browser while I make a connection on the internet, and then sends the request. But that's it. There doesn't appear to be any code that actually handles the response, but indeed there is. This thing called handler is actually a function that I wrote. If I scroll down just past the break here, notice that here is a function called handler. What is it doing? Well, if xhr.readystate, another property, this time is capitalized, equals 4, well, 4 is just a unique identifier, and the world is starting to clean these up, frankly, with constants. 4 means that everything is good, like I have gotten a response back from the server. And if that response is an HTTP status of 200, 200 being good, 401 being bad, 404 being bad, 500 being bad, you might have seen these errors on the web, 200 is good. If that is good, what do? I alert. I call the alert function and display xhr.responseText, because what browsers do when you make an AJAX request is whatever the server sends back, it tucks inside of a special property, special key called response text inside of that XML HTTP request object. Now that was version 1. Version 2, recall, just changed the actual web page, and in fact it did so with just one different line of code. Whereas a moment ago I called the alert function, in version 2 I changed quote unquote to be determined to the actual response. This is actually really easy. Document.getElement by ID of quote unquote price .inner HTML. It's not necessarily the most, say, official way of updating the DOM, but it actually tends to be one of the most efficient in terms of performance and simplest, frankly, for the first of our examples here. And sure enough, this will change the HTML inside of an element called price to be whatever came back from the server. So what is this ID of price? Well, in this version 2, if I look at my HTML, notice here I had the foresight to say price : and then I had a span tag, a span being an inline element that doesn't take up the whole row. To be determined is the default, but that span has an ID of price, and so I can very easily update that field as well. All right. Any questions on AJAX? And I promise these topics will recur over time if it feels a bit fast. Any questions? Joseph, you looked like you had a question? No? Excellent. Well done. All right, so let's then see where you can take these fundamentals. Well, we looked at jQuery Mobile briefly, but recall when we did the jQuery Mobile demo, where I essentially one-upped my own implementation of the course's website just by including a library of JavaScript in CSS, and I sort of magically got all of these nice sliding menus and such. Well, that's because, in part, it was leveraging a very popular library that's used all throughout the web, both mobile and desktop-based these days, called jQuery. Freely available. It essentially makes a lot of things easier, both aesthetically and also programmatically. So people who use this library, jQuery, they don't call document.getElementById all the time. They instead say $ parenthesis, quote unquote, foo, where foo is the ID, or sharp foo, where foo is the ID of something they want to get. So we'll defer to section and to a number of online tutorials for some of the syntax, but realize that jQuery itself is not a language. It's simply a very popular library around the JavaScript language that another library actually uses. And in fact, just to give you a sense of syntax here, all those stupid hoops I just jumped through to make an AJAX request are simplified in a lot of these libraries. Not just jQuery, but in other libraries like Yahoo's YUI and XJS and any number of other freely available tools. This, though, is how jQuery would approach essentially the same kind of functionality. Here is $.ajax. It's slightly funky notation, but it turns out in the world of JavaScript, $ is a legitimate symbol inside of a variable name, as is the underscore character. So you often see these things being used or abused by libraries for special purposes. This $ is a synonym for jQuery, lowercase or uppercase jQuery, which is just an object that is defined in the jQuery.js file that I included at the top of my own code and that a lot of people do. So the succinctness of jQuery in part comes from their sort of having decided, you can use a $. It's one symbol. It's the shortest possible function name or symbol name. Let's use it for everything. And so it actually gives you some succinctness that most libraries do not. So this is an AJAX call, but notice a couple of features now of the things we've looked at. AJAX, open parenthesis. So this is a function call. The function is called AJAX by design. Open curly brace. What does that curly brace denote? Not so much a variable, but an object. So recall, objects use curly braces. So this is a way of passing to a function multiple arguments, essentially, but really in any order. And this is popular in PHP, in Perl, in other languages as well. It's a way of having named parameters where you specify key value pairs to a function and not some arbitrary list of x, y, z, where they always need to go in that order. This is particularly useful when not all of the keys are required. They may very well be optional. So in this case, I'm using 2 keys that are expected potentially as arguments to the AJAX function. First one, or the first parameter or key, is called success. This is a parameter that's supposed to point to a function, the function I want to be called when the AJAX request comes back. By contrast, URL is another parameter, or more specifically key here, that specifies what URL do I want the AJAX request to go to. For instance, quote1.php in my prior examples. Now notice this trick here. Function, open paren, data, close paren, open curly brace. So I mentioned this notion of defining functions anonymously earlier in the world of JavaScript, and indeed that's what we're doing. I'm saying with this syntax here, it's the same fundamentals as earlier. The key is success. The value is a function that actually doesn't have a name. Notice there's no name. It's function, open parenthesis, parameter, data. So I'm saying, give me on the fly here a function that may exist only temporarily. That function should take one parameter called data. Open parenthesis, close parenthesis means here comes the implementation of this function. I'm just going to give it to you right now. By contrast, in my AJAX example before, I specified just the name handler, but recall that I only used that function once. So I'm kind of just making a mess of my code by giving it a name, only to call that same function once. I could just make an anonymous function and start cleaning up my code and removing unnecessary symbols. And sure enough, what's going to happen here is the jQuery library, if my HTTP request via AJAX is successful, it's going to call this anonymous function. It's going to pass to it one argument, which is whatever the server spit out to it. And now I can use this code, $, open parenthesis, #ID. This means go find me the div or the span or the input or whatever element there is in my HTML page that has an ID of quote unquote ID, and change its inner HTML, this is a function though here, to whatever came back. So in other words, we've taken like 20, 30 lines of code, which maybe are clear once you read through them a few times, but it's just not at all fun, and it's getting in the way of actually doing useful work, which is make an HTTP request and embed the response in the page. And that's what these 6 or so lines of code are actually doing this time. So once we have that, what can we do? Well, a second library that's quite popular, though not as well documented as even the alpha version of jQuery Mobile, is JQ-Touch. So we looked briefly at this, I think, in the first lecture with just some examples. But notice this code here. So we're not going to focus on so much the details. We'll defer this to a project. But notice that in this following example that we're about to see in a browser, there's a bunch of script tags that point to a library called JQ-Touch. There's some inline JavaScript that I wrote whose syntax is actually pretty similar to jQuery, because this library also uses jQuery. That's why you'll see the similarities. And notice that it's just calling a method called JQ-Touch. So what's interesting about this library is that unlike jQuery Mobile, where I just needed the script tag and I just needed the link tag for CSS, I didn't write any code myself. For JQ-Touch, you actually do need to write at least one line of code yourself, and that is call the JQ-Touch function. And essentially, this function is going to analyze all of your HTML code and transform it into a more interactive user interface if you followed the rules. Now, the stuff down here is just some CSS. The stuff down here is the structure of my page. Recall from my jQuery Mobile example that I kind of embedded inside of one HTML file multiple different pages inside of div after div after div. But jQuery Mobile actually takes a sort of semantically more sophisticated approach using the data-role, data-theme to kind of genericize the structure of the page. This library went with the choice of using classes, CSS classes, but the idea is the same. And frankly, it's a little simpler, at least the first time around. I have a div ID of, my div ID of quote-unquote menu up top, which represents my main menu, so to speak. I then have a div ID of lectures and a div ID of lecture 0. And I'm going to wave my hands for now at some of the specifics of the HTML, but notice mentions of classes. Class equals arrow. Class equals edge to edge. Class equals toolbar. The documentation told me that whereas the other library used that notion of role and themes, this just uses CSS classes. But the end result is roughly the same. If I now pull up this version, jqtouch.html, jqtouch.html, notice I have slightly different aesthetic version of this, but I can click lectures, I can click lecture 0, and sure enough, there are my slides if I keep clicking through there. And there's one last one then that's worth noting. So if we take a look here at this guy, we'll see a fundamentally different approach. What's interesting about jQuery Touch and jQuery Mobile and JQ-Touch is that they do rely in a large part on HTML structure to structure your page. Sencha Touch, which is arguably a more feature-rich API of all of them, is really JavaScript solely driven, whereby you don't really use any HTML markup to represent your page. You do everything pretty much programmatically. So what does this mean? Well, if we look at sencha.html, the last example here, notice again I embed some JavaScript up top and some CSS up top, simply because I read the manual as to how to embed Sencha's own library code. But then I actually need to write some JavaScript code myself. Now, if I fast forward to the HTML, the interface you're about to see uses only this as its markup. Open body, close body. And in fact, if I go to that actual demonstration in the confines of the browser, I will see here that we have, come on, tilde mailin 1. sencha.html, notice that we get a familiar looking, come on, come back. Oh, damn it. We see a familiar looking, there it is. We'll see a familiar looking UI. Colors are slightly different, but lectures at top, syllabus down below. If I go and click on lectures, it will indeed slide over to the left and give me lecture 1, keep sliding and so forth. But notice in this case, with the Sencha library, everything is done with JavaScript code. And there's a number of ways to render this, but if I go backwards up, In the Sencha world, you have this ext.setup function. You've got this property called onReady. Notice the similarities with what we just saw, open parenthesis, open curly brace. The onReady function says, do all of this when the page is ready to be rendered by the browser. Everything's been downloaded. And what you're seeing now is what this company, Sencha, calls a nested list. And long story short, the nested list is a constructor. It's an object, a constructor that takes a bunch of parameters specifying how do you want to construct this nested list, what data do you actually want to use. And so sure enough, if you spend some time looking through this code, if you choose to use Sencha for one of your projects, you'll see that up top, I indeed have some data. That data is an object. That object has a property called items. Items has a value that is what kind of data? What does the square brackets denote? An array. And so long story short, if you kind of follow the messiness that is nonetheless the clean indentation here, but kind of gets a little mind-bending, really I just have a hierarchical object here inside of which is more objects and more arrays. And that is what's ultimately representing in Sencha's world the hierarchical menus that we then see. So that there is our teaser on the JavaScript fundamentals. Let's now see what we can do in the world of maps and longer-term data.
Hi everyone, again. So now we have, actually, we're going to get to some of the really interesting things. While Ajax is very useful and very interesting, there's some pretty specific things that HTML5, at least some of the specifications related to HTML5, allow us. And specifically the ones that we're going to cover today are local storage, which is basically, you can, it's sort of like a glorified cookie, but not at all like that at all. And also geolocation, which is going to be kind of interesting. So we'll talk about each of those things. First, we'll talk about data, local storage specifically, and then geolocation. And then we'll mash the two together into this sort of GPS recorder. So there's a way that you could have a web app. You can create a web application to have your phone on and record your GPS location as you walk along a path and then display it on a map in sort of a really neat way. So hopefully in the time we have remaining, we will get to each of those things. So first, let's talk about local storage. And so local storage is sort of, like I said before, sort of like a glorified cookie. But there's some very important differences between cookie and local storage. And local storage is just one name for this. It could also be called web storage or DOM storage. But the way that we refer to it in the JavaScript land, as you will see in the code in just a moment, is with local storage. So the way that it is different from a cookie is that a cookie is something that is stored on your machine and it is sent via the HTTP header up to the server every time you load a page on that domain. And what's the primary difference between local storage and cookies is that local storage is just that. It is stored locally on your machine and it is not sent upstream unless you jump through some hoops to actually send it. So maybe you could use, for example, some Ajax to actually send the data upstream to a server, but by default it's not sent in an HTTP request like a cookie is. And also because the cookie is sent in an HTTP request, and also because of some limitations from some early on browsers, you can't store a lot of data in a cookie. You can maybe store about 4 kilobytes or so, and that's kind of pushing it, frankly. Local storage really increases that. You can store a lot more data. Right now, the browsers that implement it have kind of settled on, just coincidentally, they've settled on about 5 megabytes per domain, and that's actually a very big increase over 4 kilobytes. And this allows you to store quite a few things locally, text in particular, that you can then use in JavaScript in pretty interesting ways, as you will see, especially when we get to this combination, this GPS recorder that allows us to record a track of data and store it on our phone and then actually view it at a later time. So this is data1.html. This is the very most basic of local storage implementations. And in fact, I'm going to suggest that I'm just going to show you this code, and it's overly simplistic. Don't use this particular code. There's no checks, there's no error correction, there's nothing like that. But this at least shows you how it's done. So right now I loaded this page, and you can see that it brought up an alert box, and it says right now null. So what does this mean? What is essentially happening is there's an alert box that's showing me the contents of some local storage for this domain. Right now there's nothing in it. Now there's another line of code in the JavaScript that after I hit OK, it will actually store some data in local storage. And when I refresh the page, it will actually show you now the new text that's there. In this case, you can see it says test! So there's some text, there's some way that I'm storing this text in the web browser and referencing it at a later point in time. So how do I do this? Well, beyond the usual HTML that we've seen, there's some CSS and some HTML, but basically what I'm going to be doing is running some JavaScript, and I'm going to run this JavaScript using the onload event. You can see the body tag at the very top, and David talked earlier about how a lot of JavaScript is run based on events. When some event occurs, run some JavaScript. And so when the body has finished loading, on the onload event, it will run this JavaScript function, store_test. Okay, so that's the first step, and we're going to see variations of this exact thing in pretty much all of the examples. So I might do some hand waving about this onload from here on out, but this is basically the same thing in all of the subsequent examples. So you can see here we have some embedded JavaScript, and in it there is one function with essentially 2 lines of code that do exactly what I mentioned before. First, we're going to alert local storage.getItem. So this local storage, this is an object that exists in a browser that supports local storage. This local storage object will exist that has a variety of properties and methods. And one of these methods is getItem. Now, local storage operates in this sort of key-value pair. You can set a key and you can set a value to that key, and then you can retrieve that value from that key at a later point in time. And so to make an example of this, we can set an item. In this case, we're going to set the key foo, and we're going to set the value test, exclamation point. And it is going to store this key value pair in local storage on this domain. It's not going to store it on the server or anything like that. It's local storage. The browser is doing it for you, but this is only accessible by my domain. In this case, my key foo is only accessible by this domain that loaded the page right here. So this means that because the very first time I opened this page, when I tried to get the item, get the value from this key foo, there was nothing in it, and we got that text, null, which implies to us something very important that's going to be useful when we're doing some error checking later, and that is if some item does not exist, if we are trying to read the value of a key that does not exist, it is just going to be null. It's not going to be undefined. There's a variety of other things that it could be in JavaScript, like 0 or null or undefined. These are all distinct entities in JavaScript. But in this case, what it is returning is null. Now, once we set some data to this item, in this case, we're setting this data test exclamation point to foo. Then the next time I reload the page, then we actually will get, in this alert box, the data that has been stored there. So I said this was a bit overly simplistic, but this does show you how local storage can be very simple. It's not difficult to use as long as you remember that it works in these key value pairs. You can set items, you set a value to a specific key, and then you can retrieve the value from that key at a later point in time. So that's pretty much it for local storage. But from here, we have to do some iterative improvements in order to make it perhaps a little bit more robust, make sure that our data is actually retrieved properly. And so that's what we're going to deal with in these subsequent examples. And so in data2.html, notice that now we can actually detect in JavaScript whether or not the data has been set. In this case, we say, okay, we show an alert that says data is null. There's nothing in storage for the key bar. And so there is then this sort of iterative improvement that we've made over it that we can actually test to make sure that we have some data in local storage. So in this case, what we are doing is we're going to create a new variable and put the contents of this bar key that's stored in local storage into it, and we're going to test to see if it's null. If it is null, then we will tell the user. Like David said before, alert messages aren't really all that great to use in production websites or for a website that you actually want to have live, but it is useful because it's easy as a pedagogical tool. And so again, this is another one of those do as I say, not as I do sorts of things, but this is at least relatively short and shows you how we can do this. So if the data is null, there is nothing in storage for it. Otherwise, there is something, and we will just display that. We will alert the data. Then, of course, we will set some data to this so that the next time I reload the page, we will actually retrieve the information from there. Now, there's one other thing that we should probably check, and that is whether or not the browser can actually support local storage. A lot of the modern browsers can, and in fact, Firefox, Chrome, Safari, all of these browsers, all of the mobile browsers can support it. but it's a question if a user is using an older version of IE. I think even IE8 might support local storage, which is actually kind of impressive. But if it's an older version of IE, you're going to be out of luck, or even some older versions of most of these browsers. So we need to have a way of testing whether or not we can do this. So you'll notice that above this data, we have a function, or we have an if statement that says if supports web storage, then something will happen. In this case, we're saying if the browser does not support web storage, we're going to just produce an alert notifying the user as such, and this is not going to work properly. But how does this function work? This is a function that we had to write ourselves to actually perform the test. And so this JavaScript might look a little more complicated and a little more convoluted, but if you're familiar with some of the concepts from Java, in particular handling exceptions, then this hopefully won't look too daunting. So what we're going to do is we're going to try some block of code. We're going to ask JavaScript to try something, and if it fails, then it will go down to this catch block. We will catch an exception. We will say, okay, if something has happened that's caused me to produce an error, I'm going to just return false. So what are we going to try? We are going to return a Boolean expression. We're going to return either true or false. We will return true if the local storage, that is that object that we were talking about, exists in the larger object called window, and this window local storage is not equal to null. So in other words, this has to exist and can't be equal to null. Then we'll just reasonably assume that it's okay. Now you could do this yourself, or you could use another framework. Like we demonstrated last week, you could use that framework called Modernizer to be able to do this same sort of detection. Okay, so let's move on and go to data 3 and see what sort of improvements we can make here. Now, one of the important things to realize about data storage is that we are not storing any data except strings. Any data that you put into data storage is going to be stored as a string, and this has actually some pretty important ramifications for whenever we try to store other types of data, maybe doubles, for example, integers. We'll have to jump through a few more hoops to make sure that our data is actually correct. And so what happens here? So let's say that I want to implement a counter of some kind. And this is sort of perhaps a silly example because it's sort of overkill to use local storage, but it is at least simple enough for us to demonstrate this problem that can exist. So right here you will see when I first load the page, it says that I have visited the page 0 times in the past. So that makes sense. This is the first time I've loaded up this page, so I've not been here before. So if I hit OK and reload the page, you'll see that now it says, okay, you've been here 1 time. If I keep going, I will see that it is counting how many times I've been to this web page, just increasing by 1 every time, just with the simple incrementer. And if we look at the code, that's exactly what is happening. And in fact, in data3.html, we're going to use a new key in local storage called count. And what we are going to do is increment that data by 1 every time we save it again in the local storage. But when we first fetch the data, we're going to try to see if that data is null. If it's null, then we need to set it to something reasonable, say 0, and then we can start incrementing from here. Now you might say, okay, well this doesn't seem to have much of a problem, because if it's storing as a string and then it's fetching the data and it's still allowing us to increment it, then what is the problem exactly? Well, the problem is that JavaScript is able to implicitly change the type of data from a string to an integer without much of a problem, but we don't have any sort of protections in case this data isn't an integer. Let's say I have here a link that says mess up counter. And this link is not so much a link to a URL, but instead it is a link to a JavaScript function, like you can see here, that calls this function mess up. So if I look at mess up, we can see that we're going to store in this local storage count key a string called test. So if I do that, then the next time I reload the page, what might happen when I try to do this to that data? Any ideas? What might happen? If I try to increment test with this ++ incrementer, what will happen? I take your silence as meaning you have no idea, which is actually kind of a good thing, because it's undefined. Like, what is going to happen? Can you actually increase this test string by 1? So I'm going to mess up the counter. And now what it does is it actually called that same function again, which is going to show the alert. We can see that the alert, you have visited this page test times in the past, whereas before we actually had an integer. So if I hit OK on this, now reload the page, what's going to happen is that, recall that after the alert box in the code itself, here you can see the code that says you visited this page data times, and the data was that string that said test. Then it tries to increment the data by 1 and store it again into local storage. So the next time I reload this page, it will show me the result of this increment. So what I'm going to do is reload the page, and now it says that you have visited this page NaN times in the past. Now this is getting a little bit wonky, right? What's going on here? Well, in JavaScript, there's this concept of not a number, NaN. And what's happening is that it is trying to implicitly typecast this string test into a number to increment it, and it can't do it. So what it's saying is that, okay, test is not a number, so that's what it's storing, NaN. It's NaN, and it's not able to increment. So now, this is the problem that arises when you're trying to work with numbers that you're storing in local storage. So how do we fix this? Now, to prove to you, now there's this data4.html is actually a two-pronged approach. One, it's to prove to you that no matter what we have stored, it is pretty much counted as a string. And two, we will actually show you the fix for this. So in data4, the first alert box that appears is the type of data that exists in the local storage. In this case, it is a string, and specifically, it is that NaN string. But we will see that even when we reset the counter to be an integer, or what we think is an integer, it will still say that it is a string. Okay, so after string, I'm going to hit OK. And now you can see that even though it's working with the same data, it tells us it has done something correct. It has handled this error properly, and it says, okay, I don't understand this data that used to be here, but I will instead reset it to 0, and it will start the counter from scratch. So how do we fix this problem in particular? We can look at the data4.html code, and where it starts to get interesting is here. So what we want to do is take the data, and we want to parse that string as an integer. So we are explicitly now asking JavaScript to convert this string into an integer for us. Now, that might still result in that NaN, and that not a number, but we can detect that now. We can ask the question from JavaScript if the data is null or if that data is not a number. If either of these is true, because either the data doesn't exist or because the data is not valid, we will reset the data back to 0. But by explicitly changing our data to what we want it to be, if instead we were storing maybe some coordinates, for example, and we wanted to get the double coordinates out of it, then we might need to do something like parse double or some similar thing. For any variety of data that is not a string, you will have to be sure that you handle it appropriately from local storage. Now, this is pretty much all the fix that's needed, because it doesn't matter what we had before, whether it was the word test or that string NaN, it will reset it back to 0, and we will then see our counter start to increment appropriately. And just to prove that, I'll restart it, or rather reload it, and notice that even though we now have a valid number within it, 1, for example, it still says that the type is a string. So this is just sort of to prove to you that what the data type that local storage uses is string. And after string, we can see that we have visited this page one time in the past. And again, reloading the page, our incrementer works fine. And now this same mess up link actually exists. And if I click on this, you'll notice what happens is that it doesn't deal with that same issue that we had before, where you visited this page test times in the past, nothing like that. It does actually work appropriately. Now, reset counter, that allows us to completely remove, via a JavaScript function, the key value pair that exists in local storage and essentially reset it. So if I restart it now, or rather reload, you can see that now what is happening when I try to figure out the type of the local storage, it's saying that it's undefined. I mean, null doesn't have a type, so that sort of makes sense. And if I hit OK on that, then you can see that it has indeed reset the data. So this link reset counter is actually just calls another function, and this function calls the local storage method remove item. So in this case, we're just asking the local storage to remove its key called count from its list of storage before it continues along with that. Now we're sort of moving kind of quickly through this stuff, but just that's so that we can get through to some interesting things. Are there any questions on this before we move on? So one of the things that's most interesting about local storage is not this small amount of data. Arguably, you could do all of these same things with cookies. And there's not a whole lot yet that really makes apparent what is nice about local storage. Well, now what I can do is have something that looks like data5.html. And now instead of having like a counter or something that stores a very short string, I can have a huge text box that allows me to put any number of or any length of string into it. And in this case, what I'm going to do is just go to a lorem ipsum generator, which, if you're familiar, is basically just some Latin words that are used typically to denote just some typical words, even though for us it's not really meaningful. So here I have a whole bunch of stuff in this text box. And so what I can do, if I scroll down in this page, I actually have a variety of buttons down here: save data, fetch data, and reset. So just to prove to you that this works, what I will do is I will save this data. And now I could have done an alert box or something to notify the user that the data has been saved, but that's a nicety that's up to you to implement. But now I can try to change this text box just with some gibberish. And now what I will try to do is reload the page. You'll see that what happens is that it is fetching, when on reload, all of the data that's stored in the local storage and puts it back into this text area. So how does this work? This is very similar to what we have already seen. It's just sort of a more useful example. Again, we're going to use this function that makes sure that our browser actually supports web storage. And at the onset, on the body load of this web page, we're going to do two things. First, we're going to make sure that that our browser supports web storage, and then we're going to run this fetch function that will fetch all of the data in local storage and put it into the text area. So how does fetch work? It's very similar to what we have seen before. Now notice that I think in between data 3 and data 4, one of the interesting things that changes is the way that we reference some of this data. You can actually use that get item and set item methods that exist in local storage, or you can also reference local storage like an array. So in this case, whereas before, back in data2.html, the way that we set the data was using something like this, local storage.setItem method, and then provided to it the key and the value that we wanted. But there is another way that we can do it, and they're both valid. You can use either one, whichever one sort of you find best. You can also reference it like it's an array. So as though it were an associative array, and you wanted to reference the value from the key myText in the local storage array. Either one is valid. You can use either method that you prefer. This one is just sort of shorter and nicer, so I'll use this method from now on. But I will retrieve the data that I'm from this key called myText, and then I will make sure that it is null, or that it is not null, rather. If it is null, I'm going to tell the user there's no text in storage, like we saw when I first loaded this web page, and then I'll abort fetching the data if that is the case. Otherwise, I will set the value of this text area equal to the value of the data in local storage. So very much like what we saw before, where you can you can retrieve the data and actually do something with it. Now, to save the data, it's very easy. You just save the value of the text area into the local storage with that key, and then that data is saved in the local storage. Then, of course, if we wanted to reset, we would use the remove item method. So this is just sort of a more useful thing that shows you that we can store large amounts of text in local storage without much of an issue. Any questions on this? Okay, now I think what some of the really fun things arise, in fact, from geodata. And using the ability to use geodata is actually really interesting because then you can pinpoint a user's location. Now, using it on a desktop machine is arguably not going to be all that useful because we don't actually have GPS chipsets within our laptops or within our desktops. The best that we can do, although many modern browsers, including Safari and Firefox and Chrome, do support the geolocation features, they're not going to be very accurate. They're going to try to identify where you are based on your IP address. And so when I was sitting at home at my apartment, for example, it pinpointed that I was approximately in Cambridge, but it said that the radius, the error, was so huge that I could have been anywhere in Massachusetts or in half of New Hampshire. It didn't know exactly where I was. So if I try to look at some of the geolocation, what exactly happens behind the scenes? So when I first click on this, notice that it gives us a question. It asks us a question, do we want to allow this website the use of our geolocation data? And all web browsers that support geolocation will show you something similar to this. They're going to ask your permission if you want to provide this data or not. So you can either allow it or disallow it. And if I allow it, what will happen eventually, and it's not actually going to work in Safari, I'll have to show you in a different browser. What will happen eventually is that it will tell me my latitude and longitude in an alert box. So here in Chrome, for example, I hit return and I've already accepted it in Chrome, so it came up right away. You can see my latitude and longitude, and you can see the accuracy. The accuracy is given to us in meters, and so 42,000 meters, 42 kilometers, that's actually not very good of an accuracy. And in fact, it's sort of interesting here, the accuracy does seem a little bit better than it does elsewhere, and I think part of the reason is that because we all have IPs on Harvard's campus, I think many of the geolocation frameworks are able to figure out where more precisely we are. Let's see if I refresh. Nope, it doesn't actually show me anything else, but there's also a timestamp. The timestamp tells you the last time that this data was retrieved. And sometimes this will actually be useful, particularly when we want to refresh this data fairly frequently. So how do we do this? Well, like the data one, we're going to just show a very, very basic example of how to do this. So we have a very simple HTML file. The very first thing that we're going to do on load is called the geo function. And in the geo function, we're going to run this, navigator.geolocation.getCurrentPosition, and then pass into it as parameter something. That something is the name of a callback function that David had mentioned and described before. And when this current position has actually been retrieved, it's going to call this function with the position, and we can do something with that data. And in this case, there's a variable called position that has a property called coordinates that has itself a property called latitude, longitude, and accuracy that tells us each of these things. There's actually some additional data that some of these that some browsers will tell us as well, like altitude accuracy, the heading if you're actually moving, what your speed is. But you can test for these because if any of these are not present, they will be equal to null. So this is a very basic thing, and again, this does not have any sort of error handling. Like when I tried to do this in Safari, you can see that nothing has actually happened even though I approved it. And that's where Geo2 actually comes in. This actually does have a little bit better error handling. So what we should see is now we're going to test, first of all, that our browser has the geolocation capability. And we're just going to do that by asking the question, if the navigator has a method called geolocation, or rather an object called a geolocation, then we will get the current position. Otherwise, we will tell the user that that it is not supported by their browser. Now, one of the nice things is that we have an additional parameter called handler, and this can actually handle error codes. So what will happen if this current position happens on success, we will run the print geo. Otherwise, we will run handler, and we can actually print out an alert with the handler function. Now, you can actually take each of these to their logical conclusions, local storage and geolocation. But what you can do is then create a GPS recorder, like you can see here, which I use to actually record a portion of my journey from home to Harvard. And you can actually see on a web app the track that I took in my car, and specifically, some of the sliding that I did in the snow. than that I took to get here. So before we were looking at how we can actually create, using local storage and geolocation, a track. But before we can do that, we do actually have to deal with some of the specifics of geolocation first. So I mentioned before that Geo2 actually allows for some error handling, and we can see this if I reload the page. And in this case, if I don't allow permission to this website to use my location, and I hit don't allow, we see that we get an error message. User error number 1, user denied geolocation. So you will have to handle this case in some nice way rather than just providing an alert like, you really should give me your location, otherwise this isn't going to work, just because not all users will provide that information. And in fact, it's very easy in most of these browsers to completely disallow it for all websites. So for example, here there's a checkbox in Safari's preferences called location services, allow websites to ask for location information. Just by unchecking that, will I then always get this problem that I see before, that error number 1, where I will not be able to do anything with that. So if I uncheck this, just to show you what will happen and refresh this page, you'll see immediately, do I get this error number 1, and I have to handle this effectively. All right, but for now, for these demos, I do actually have to have location services on, and we will move on to Geo3. Now, what will happen here, whereas before what we had done was provided this information in an alert box like you saw when I was using Chrome. Here we showed this information in an alert box, and here look at our accuracy, 65 meters. That's actually really, really good. So now we're getting pretty specific with our accuracy. So that latitude and longitude is relatively close to where we are located now in this room. But the difference between 2 and 3, in fact, has to deal with the timestamp itself and where this data is actually shown. So if I skip ahead from Geo1 to Geo3, here we can see that now instead of having to deal with alert boxes, I'm now actually inserting it into the DOM using a trick that David had shown before, using this inner HTML trick. And another thing that we see is no longer was that timestamp very ugly, whereas before the timestamp is given as seconds from something called epoch, or basically some date around 1970, we can now format it into a usable string that we can actually read. So we can say, okay, now I know that this data that I retrieved, which is no longer accurate for some reason, was actually retrieved somewhat recently, about a minute ago or so. So how do we do this? Well, to do this, we can look at a couple of things. First of all, what I want to do is look at the error handler. Now, no, not the error handler, the code that inserts into the HTML. So when you know that when we retrieve or when we ask the browser for the geodata, what we are doing is we are sending the data to this function called printGeo, just because of that callback function. The reason that we use this callback function is because the user is going to take time to decide to read that little dialog box that asks for permission, and is going to take some time deciding what to do. And even if they know immediately what they're going to do, it still takes them some time to notice that there's a box up, move their mouse over, so on and so forth. So instead of blocking all of this JavaScript from happening, what it does is it allows that the user to either accept or deny, and then it actually performs the geo lookup, which itself can take a few minutes. In Chrome, it's actually been pretty quick, but if we were to do the same thing in Firefox, we will see that it actually takes quite a bit longer to do the same thing. So here's Firefox. You can see that it's asking me in a slightly different way. It's all the way up here. I can click Share Location, and it's not sort of coming up immediately. It's still sort of waiting, and we'll be waiting for a while in Firefox, frankly. I noticed that for some reason here it doesn't seem to work so well. But how did we actually do this? We just insert into inner HTML just a bunch of strings with BR tags at the end that represent all of this data that we retrieved from the geolocation itself. Now, the timestamp that's returned is actually in a format called the DOM timestamp, and you can actually put that into a date object and get out of that date object basically a locale string. So it's a string that's formatted to whatever locale the user is in, whatever locale settings they have on their own computer, so that you can actually see this timestamp information in a human readable format. Now, we saw before that some of the error correction, or rather the error handling that we had before was overly simplistic. We had an alert with an error code number and we printed out the error message. Now typically this message should not be shown to users, but I'm displaying it here just so that you can see what the message is from your browser. In Geo3 we can actually determine which error code we have received. Now there's three major error codes. There's permission denied, and that's the case that the user does not allow us to view their location, to view their position. Position is unavailable. That might be because the browser just can't determine the location that they're in. Maybe it's an IP address that belongs to the International Space Station, for example, and they have no idea where that is at any particular moment in time. Or, well, I mean, you could figure it out, but the web browser may not know that. There's also a timeout issue, which will become more apparent in a little bit when we actually set a timeout. And then also we want to make sure that we have a default error condition, that there's some unknown error that has occurred that we don't actually recognize. We'll have to handle it a little bit separately. So this is a little bit better of a way of handling the errors that can occur from failed geolocation. Now, we keep building on to this method, this get current position method, and in fact, now already have we seen what the handler, rather the callback function that gets called when there's a successful geolocation. There's the error handler function, but we can also pass to it an object full of options that allow us to specify a number of things about what happens when the geolocation is actually performed. So that's what's happening up here at var ops. And what we're doing is we're creating an object and we're saying a couple of things. We want high accuracy. Now, this is not something that's going to matter so much for desktops, for laptops, for phones that do not have GPS chips, but this will matter for phones that do have, or mobile devices that do have GPS capabilities, because setting this enable high accuracy property to true will actually cause the phone to use the highest resolution GPS setting that it has available and give you the most accurate position possible. Now, there might be some web apps that don't really need this sort of accuracy. For example, if you're going to do a weather application, you don't need to know exactly where the user is. You just want to know sort of approximately, maybe in about what city. That's probably good enough resolution to know for the weather, or maybe like a movie theater app or something like that looks up local movie theaters. But for something like GPS tracking, where you actually need to give turn-by-turn directions, or you actually want to allow the user to record their actual location, then you will want high accuracy. Now, timeout is the amount of time in milliseconds that we will give the browser to try to find a GPS location. In this case, because it's milliseconds, we divide by 1,000. This is 60 seconds of timeout. So what we're telling the browser is, I'm giving you 60 seconds to try to determine the user's location. If you don't find it, then you have to submit an error code. And in fact, that's what's going on over here in Firefox. There was a timeout. It was not able to determine my location within the timeout period, and so it has provided an error for us. And I think the same thing has happened over here in Safari as well. Timeout when determining your location. So for some reason right now, Chrome is the only browser that is giving us good geodata. Maximum age is useful because all of these browsers will cache the GPS position for a certain amount of time. And with maximum age, you can tell the browser the oldest GPS data that you're going to allow. In this case, 60 seconds, I'm saying, is going to be the maximum time before I want the browser to try to fetch new geodata, perhaps because the user is moving and you therefore are expecting them to make some significant headway in distance in 60 seconds. You can increase or decrease this depending on the capabilities that you want your web app to have. Now, all of this is well and good, but this only allows us one thing. This only allows us to get the current position once. We could do something fancy, like we could set a timer and we could try to get the current position over and over again whenever this timer fires. But there's another method that exists that does all of the work for us. And that is provided to us in Geo4. And in Geo4, what happens is you will see as the GPS coordinates are updated, it is actually updated on our page. So we can actually see what's happening to our accuracy. We can actually see what's happening to our latitude and longitude as it gets perhaps a little bit more accurate. This happens especially on phones. So the first time the phone tries to get a GPS location, doesn't have a good fix, and so it takes a long time for it to pinpoint your location, this can be very useful for that sort of thing. So how does this work? We use a different function altogether that still accepts the same options. It's just slightly different in name. So we can still provide it the same options, which have all the same meaning as before. We still provided a callback function for what happens when we have retrieved the data, and an error handler function when we have some error. But rather than use that getPosition method, we use watchPosition. And watchPosition will do this. It will monitor the position every time it changes. It will update by calling the printGeo function in this case, to update the map or to update the web page with the most recent position that it actually has. Now you'll notice one other thing. In this case, we're setting a new variable that I've called watchID equal to the result of this watchPosition method. Before we didn't do that. We just called that getPosition method, getCurrentPosition method here, and it didn't return anything. But the reason that this watchID is useful is that this watchPosition will continue watching and watching and watching until you actually tell it to stop. And in order for us to know when to stop, you have to know the ID of it, and then you can run this separate function altogether called navigator.geolocation.clearWatch and pass it the ID that was returned by watchPosition. Then you can actually stop. So Chrome right now in the background is still refining or is still moving around, and there's actually a new link here that says click here to stop that runs that stop geo function and then clears that watcher method from running anymore. So now the data will not be updated until I reload this web page. Otherwise, it's largely the same. Now, one of the main improvements is using this inner HTML. Had we used alert boxes, this would have gotten annoying very, very quickly because it would have kept popping up alert boxes every time it updated our information. So doing something other than alert boxes is useful in this case. Now, all of this is well and good, but we don't really know what these latitude and longitude numbers actually mean. It's most useful and it's most fun for us to actually put them on a map. And sort of skipping ahead because we have not actually had a chance to go over Google Maps or anything like that, we can actually put all this data on a Google map just with geo5.html. So in this case, what we are going to see, hopefully, is my current location and a circle showing me the accuracy of the geolocation that I have right now. And right now, this is actually pretty good. When I was, like I said, when I was at home and I was trying this, the circle was big enough to encompass several states. But in this case, because of the IP range, I suppose, that we have here, it actually has a pretty good fix on where we are. It's relatively close to our actual location. But how does all of this actually work? Well, if we take a look at the Geo5 code, now realize that there's quite a bit of code here that deals with loading and instantiating a Google map. And for that, if you're interested in doing that, I recommend looking for the Google Maps API, which you can find just by Googling around, frankly. And it shows some very good tutorials, some very good ways of getting started with the Google Maps API. I'll talk to you a little bit about what is going on here, but you'll have to probably do some investigation on your own. Specifically, in order for us to run the Google Maps API, we have to load their JavaScript, which we can do with this simple script tag up here and reference the maps.google.com/map/API, their JavaScript file from there. There's a sensor equals false, and that actually deals with using hardware device to show you the location, but since we're doing that through a different method, we will set that to false for now. Now, when the page loads, we need to do some things like set some options for the Google map. In this case, this is very similar to what you've seen before by creating an options variable that is an object that contains some key value pairs that actually describe the options that we want to provide this map. The specifics of these options I'll leave to your research on the Google Maps API, but suffice to say that zoom is pretty obvious. It's the default zoom of the map. The center of the map is also pretty obvious. It is the default location that the map will be centered on. In this case, it's just a generic place in Cambridge. I think it's just the center of 02138, perhaps, that correspond with this latitude and longitude coordinates. Now, once we have actually created the map and we've instantiated it using this new Google Maps.map, and notice that we do that by passing in an element whose sole purpose in life in the HTML is just to show the map that we're going to instantiate from the Google Maps API. Then we're going to actually try to fetch the geolocation data from the user. So we will run this geo function that looks very similar to what we've already seen, navigator.geolocation.getCurrentPosition, with the same thing, print geo, and we'll pass in a handler, and we'll have all of our error correction, or all of our error detection rather, to determine whether or not geolocation is actually supported by our browser, if there's any errors that we have to handle. Now what's interesting here in the print geo function is that once we retrieve the latitude and longitude, it becomes very easy to create a marker and display it on the map, and to create a circle that represents the radius of accuracy and display that on the map as well. So here we can see that I'm creating a new variable called lat_long and putting into it a new lat_long object from the Google Maps API and passing into it the latitude and longitude coordinates that was provided by this geolocation. From there, I can then set the center of the map to this point, because that makes the most sense to center the map on our newfound location. And then I also want to display a marker by instantiating a new Google Maps marker and passing in an object full of options of its own. In this case, you can see we're setting the map that it's going to display on. We just want a simple drop animation when, as you saw when it first loaded, it sort of dropped the pin right there, which was kind of cool. And we also want the position itself of the marker. In this case, the latitude and longitude that we determined via geolocation. Now for the circle, this is also pretty easy. We just create a new Google Maps circle with certain color and opacity, and we provide it the same center as this marker, and we also tell it that the radius is the accuracy of our geo lookup. Pretty simple, right? We're now able to do something fun and useful with this geolocation. Now, the next thing to do is to actually make sure that the zoom level of the Google Maps corresponds to the size of this new circle, because if it's huge, we don't want to be really zoomed in. If it's very small, we don't want to be very zoomed out. So we will tell the map to fit its bounds dependent on the circle's bounds itself, however big the circle has been placed on the map. And so the result is this right here. So now you can see this is the default center. There's been no location, and as soon as we get the location from the geolocation service, then it drops the pin in the location that we want. Okay, so now this is using that get location, the static get location. This is the location that's sent to us only once. But what if we want to have a live updating map as it's sort of refined? So now you can see what's happening here as it tries to continue fetching geolocation data, and the accuracy changes. When it changed to be very, very inaccurate, then it zoomed out quite a bit, and it showed you that huge circle. But now it seems to have settled on this location right here. And frankly, this is a very tough demo to do here. It's much better if you load up this geo6.html on your Android or iPhone and sort of walk around and see what happens as the map actually follows you, and as the circle becomes smaller, as it starts to pinpoint your location. But it's a very similar thing to what we saw in Geo5, except for a couple of important differences. First of all, one of the things that we're going to do, instead of using the get current position, is to use, of course, the watch position. And with watch position, we will send all of the data from that to MapGeo, where we will handle all of this data. So this is very similar. I'll have to do, unfortunately, some hand waving here so we can get to some of the fun stuff in the GPS tracker. But basically what we want to do is just determine if a marker and circle have already been created. If not, we'll create them at the default location that we have, or the initial location that we have from the Geo service. Otherwise, if they're already set, then we will just update their location and the size of the circle dependent on the new data that we have from this geolocation service. So all we will do is reset the position, reset the center of the marker and the circle respectively, and then change the radius of the circle to match the new accuracy that we have from our data. And that's pretty much it from here. But now we've talked about two things separately. We've talked about local storage, which is sort of neat in that we can store a lot of data. And we've talked about using geolocation to pinpoint our location on a map. But what if we wanted to combine the two and record the track? Let's say I'm actually walking along a path and I want to record my track and actually view it on a screen at a later point in time. Well, the way that we can do this is actually shown by, instead of the geo functions, these track pages. So there's a couple of pages here, record, show, and show raw. And what we're going to do is each of these, in record, what we're going to do is actually record the data. In show, we will apply that data onto a map, and show raw will actually show you the raw data that's applied or that's been saved in the local storage. So this GPS tracker app is broken down into 3 files. Really, it only needs 2, but 3 is there to sort of show you what's going on with the data behind the scenes. So there's this record.html app, or rather web page, and what it does is it uses that watch method in order to continuously update your location, and it shows you your location. And basically, what's happening is that behind the scenes, it's recording all of this data. It's putting the latitude, the longitude, and the accuracy into a large array. And it's continuously updating this array, and every time it updates the array, it's saving this array. It's collapsing the array into a string representation using JSON, and it's collapsing this data and storing it into local storage. Then when this is all done, or as soon as you're done with your track, you can then view the track that has been recorded. You can either view the raw track and see what's actually stored in storage. In this case, we don't have a lot of GPS coordinates just because it's very motionless. We haven't done any much updating. We can see that this is JSON. This is an array of objects that contains some key value pairs, including latitude, longitude, and accuracy. So this is what's stored in the local storage. And because we have 5 megabytes, we can store quite a few of these points in storage. So then, when we actually want to see what this looks like on the show your track, then we can click on that. And what this does is show your track then loads the Google Maps that you saw before, and it will then fetch all of this data from local storage and display it onto the screen. So now you can see, okay, well, there's quite a big change here. So on our computer, when we look at the GPS track on our show.html page, we can see that first we started out with probably a pretty inaccurate location, and as it became more accurate, it actually started to pinpoint our location a little bit better. And if we look at the actual GPS track that I used on the drive over here, we can see that a similar effect has actually happened. This is when I first started recording the data, but it actually thought I was all the way over there. The accuracy at first was not very good. Now, there is a way that we could fix this. Whenever we're loading this data and drawing the Google Maps polyline, we could look at the accuracy data that we've stored in local storage, and if it's really terrible, if it's really off compared to all of the other accuracies that we have in our data, then we could just throw that data out and not use it, and that would make this a little bit better. But you can see that the accuracy actually got to be pretty good. You can actually see the exact path that I took, and hopefully a little bit, maybe some of the slides that I took around some corners because it's really slippery. That sort of stuff was actually fun. Okay, so right here it's not super accurate. Either the GPS is off very slightly, but it looks to only be a few feet off, or the map itself is off. Most likely the former is the case. But all we're doing in this show.html is just iterating through these objects that exist in local storage, or rather we take the string that has stored all of these objects in local storage, we've converted it to a JavaScript array, we just iterate over each and make each into a latitude and longitude point for Google Maps polyline and display that on a Google Maps map. And so with that, you will be able to go home and hopefully take a look at some of this code, or maybe it will be shown a little bit as an example in section or what have you. But you'll be able to look and see how we can use both of these things, both of these HTML5 things, to make a sort of interesting and kind of compelling web application that can operate just off of a simple HTML page on your mobile phone. So with that, thank you all for coming, and we will see you next week when we start diving into the native Android SDK.